All right, hey guys, I'm going to go through the 7.2 warm-up from today, Monday, March 23rd, on the answers that we should have had here. So in number 1A, we're verifying that cosine theta equals sine theta times cotan theta. This one should have been pretty simple because we're just simplifying cotan into cosine over sine. The signs cross out and we get cosine theta equals cosine theta. So of course that's an identity. In number 1B, there's a couple different ways you could have done this one. What I did here was I multiplied both sides by sine x plus cosine x to get 1 plus tan x equals secant x times sine x plus cosine x. I distributed my secant x in. I made secant 1 over cosine to get sine x over cosine x plus cosine x over cosine x for the right-hand side of the equation. Make sine x over cosine x tan. Cosine x over cosine x, of course, makes 1. So we get, does 1 plus tan x equal tan x plus 1? Well, of course it does because addition is commutative. So that's how I did 1B. Another way you could have done number 1B over here on my notebook paper. A little bit longer, convert tan into sine over cosine. So we have 1 plus sine over cosine divided by sine x over cosine x. Does that equal secant x? So when we find our common denominator here and combine these fractions in the numerator, I get cosine x plus sine x over cosine x over sine x plus cosine x. Does that equal secant x? So when we keep change flip this, our cosine x plus sine x is crossed out, and I get 1 over cosine x. Is that equal to secant x? Of course it is. 1 over cosine x is equal to secant x. So a couple different ways you could have done this. You could have ended up getting secant x equals secant x here to verify that it was an identity, or you could have gotten 1 plus tan x equals tan x plus 1 to verify that it's an identity. So either way. Okay, and number 2, oops, I'm not meaning to zoom out there. In number 2a, we are finding a numerical value of 1 trig function of x. So ignore my crossouts here. So I have 1 plus tan x over 1 plus cotan x. So I'm going to make cotan 1 over tan, because that's what cotan is, equals 2. So when we find a common denominator of the numerator, the denominator, we find a common denominator of the denominator here, 1 plus 1 over tan x. And then we keep change flip that. So we end up getting 1 plus tan x is crossed out. So we get tan x is equal to 2. So there's a trig function, 1 trig function of x to get tan x equals 2. So another way you could have done number 2a is by making tan what it is, make cotan what it is. Again, crossing out those, finding the common denominator, keep change flip, cross out the sine x plus cosine x. We end up getting sine x over cosine x equals 2, which of course is tan x equals 2. So either way, number 2a, we should have got tan x equals 2. Okay, in 2b, we should have ended up getting cosecant x equals secant x. So look through my answer key here for this one. I made tan what it was. I then went ahead and multiplied the numerators here, found a common denominator, and then just kept simplifying. All right, in 3a, so when we're using our graphing calculator, y1 is the left-hand side of the equation and y2 is the right-hand side of the equation. So y1 is 1 over sine squared x plus 1 over cosine squared x. I simplified that down using my common denominators. I end up getting 1 over sine squared x times cosine squared x. But either way, it doesn't matter when you take a look at these two graphs on your calculator. y1 does not match y2. So these two graphs, of course, do not match each other, so it's no. In 3b, left-hand side of the equation is y1, right-hand side of the equation is y2. Check both of these graphs in your calculator. You'll see that, yes, they are, in fact, the exact same graph. You might have to adjust your window a little bit, but they are the same. Okay, so if you need to see the graphs for those, let me know, because I can show you on my graphing calculator how these graphs are the same in 3b and how they're different in 3a. All right, so that's our 7.2 warm-up. Let me know if you still have any questions.